All right, Sydney, what do I do first? Divide by 4, good. Let's pay attention, come on. All right, so Mason, now what do I do? I know, that's why I always ask good questions. How to get rid of the cube root?
You have to. I don't.
How to get rid of square root? Square both sides. So how to get rid of cube roots? Yeah, cube both sides, right? Okay? So, we have x plus 7 on the left because the cube root and the cube cancel each other. And we have 8 on the right. 2 times 2 times 2. And then we subtract 7 and we're done.
Yeah.
Taylor, did you remember to check the radicand?
Yeah, did you remember? What is that?
Do we have to worry about the radicand?
No.
Why not?
Because
Because what? Very good, Vincent. We have an odd index, so it's okay for the radicand to be negative, right? It's when it's even index, square roots, fourth roots, sixth roots, that we have to do x. If that was square root, we would have to do x plus 7 greater than or equal to 0. Have to do that to make sure we don't have any negatives under our radical sign. All right? I didn't have a picture of our homework, but we can go over the homework answers. We started at 24, right?
Yeah.
All right, number 24 was x equals 4. Number 26 was x equals 81. Number 28 was x equals 1. Number 30 had 2 answers, 1 and 2. Both work. How far did we go? 40, right? 32. Got it on the back here. I gotta find it. All right. Number 32. 25. X equals 25. It would be 8x to the 3 halves equals 1,000. Is that what they told us it was in the beginning? Oh, we had to see what was wrong. So, yeah, if you do it correctly, you got to divide by 8 first, right? That's what they didn't do. Okay. The way it's written, yeah, you would have to divide by 8 first. All right. Number 34 is 0 is less than or equal to x, which is less than 64/49. I don't have the decimal for that. It'd be 1 point something, right? 1.2 or 3. 36 is x is less than or equal to 129. 38, x is greater than negative 220. And 40 is x is greater than or equal to 0. That was it, right? 24 to 40 even, right? Any of those you'd like to go over? Jordan? Sure. So 5 minus x to the 1/2. Minus 2x equals 0. All right. So is the part that's being raised to the 1/2 power isolated yet? No. So I have to add that 2x over. first. So I have this. 0 plus 2x is 2x. All right, so what do I have to raise that to get rid of the 1/2? The reciprocal, right? 2 over 1, or just 2. And again, what you do to one side, you got to do the other, right? So it's the whole thing, the 2x is raised to the second power. So I just have then, because those cancel, the 1/2 and the 2 cancel. Because remember, 1/2's like square root, right? So it's like the square root and the squared canceling each other out. So I get 5 minus x on the left, and 2 squared is 4, and then x squared is x squared, right? So, excuse me, we have a quadratic now. And I got a 5 and an x on the left. I got to set it equal to 0. See if I can factor it or use the quadratic formula. So I'm going to subtract the 5 and add the x. So I can solve it. Okay? So let's just use the quadratic formula because, you know, this will factor, I think, but we'll just do that for practice on the quadratic. So b is what? 1. Thanks. What's a? 4. And what's c? -5. Over 2 times a, right? So negative b plus or minus the square root of b squared minus 4ac over 2a, right? So, give us some room here. All right, 1 squared is 1. -4 times positive 4 is -16. -16 times -5 is positive 80. That works out nice, because what's the square root of 81? 9. So I've got -1 plus 9 divided by 8, and I have -1 minus 9 divided by 8. -1 plus 9 is positive 8, divided by 8 is positive 1. And -1 minus 9 is -10 divided by 8, which is -5/4, right? 10/8, 5/4. You could write -1.25 if you want. Does the -1 work? I think it does, doesn't it? 5 minus a negative 1.25 is a negative, or positive 6.25, right? And I could take the square root of that. So I think both answers are good. Did I say that was the answer for 28? You said just 1, so maybe that isn't a good answer. The -5/4. All right. Oh, let's see. That would be 6.25. The square root of 6.25 is 2.5, I believe. Let's do that, make sure. Square root of 6.25. Yeah, 2.5. All right, so I got a 2.5 minus 2 times -1.25. And what's 1.25 double? Positive 2.25, right? That would be this. So that's not 0, is it? That's 5. So that's why that didn't work. So that's not a good answer. Anything else? All right, so inequalities, radicals, and rational exponents. Rational exponents, we did the reciprocals. The radicals, if it was square root, we squared both sides, cube root, cube both sides, and so on, right? Okay, so today we're doing function operations, all right? So we're gonna add, subtract, multiply, and divide functions. So basically it's just combining like terms. Okay, but it's just function notation. It's pretty easy. Okay? So let me get to the, all right. So the operations are add, subtract, multiply, and divide. They're gonna ask us about domains. All right, domains are what values? Yeah, all of what values then? Well, yeah, a lot of times it's real numbers, but what values of a function are the domain? The x values, right? And the range was the y value, just terminology again, or the f of x values, right? Again, it's gonna ask you about domains and stuff, but I'm not gonna worry about you guys telling me that stuff, all right? We're just gonna work on add, subtract, and multiply, and divide, okay? So, if f of x is 5x, and g of x is x plus 2, if I want to go f plus g of x, I'm just going 5x plus x plus 2. That's all that means. And then just combine like terms. What's 5x plus x? 6x. So this is 6x plus 2. Okay? So if it says f minus g of x, that means 5x minus x plus 2. All right? When you put a minus in front of the x plus 2, what happens to the x and the 2? William, come back to us. When you put a minus in front of parentheses for x plus 2, what happens to that x and the 2 that are inside? They become negative, right? So that's what's going to happen. Okay, this is going to be 5x minus 1x, 4x, and nothing minus 2, negative 2, when we subtract it. Again, you guys have done this before. It's just in function form, that's all. There's no symbol between f and g, that means to multiply them, right? So if it's f of x times g of x, it means 5x times x plus 2. Well, how do I multiply something out front of parentheses? What do we call it? Distribute, right? That's all we do. 5x times x plus 2 is 5x squared plus 10x. Okay? And then the last one, f over g, means f divided by g, right? So it'll be 5x over x plus 2, and nothing you can do there. Nothing you can do to simplify it. Okay? So that's what we're doing. Get that out of there so you can see. All right, so the domains of the sum, difference, product, quotient functions consist of the x values that are the domains of both the. Additionally, the domain of a quotient does not include x values where, you can never have 0 down there, right? But again, I'm not worried about domains, okay? All right, so here's one. F plus g. So this would be f, which is 3 times the square root of x, plus g, which is negative 10 times the square root of x. All right, so what's 3? Are they like terms, first of all? Yes, so can I add those? Yes, so what's 3 plus a negative 10? Negative 7. We all okay with that part? Again, it says state the domain, don't worry about it. We all know that the domain has to be all real numbers greater than or equal to 0, because it's the square root, right? Even index. Now it says evaluate f plus g of 4. Okay? What's that mean to do? What do I do with the 4? Fill it where? For the x. Yeah. So all that means then is negative 7 times, so we just take the 4 and put it in for the x. So what's the square root of 4? 2 times negative 7. That's negative 14. That's how I would do it. If you wanted to, you could do 3 times the square root of 4 plus a negative 10 times the square root of 4, which would be 2 times 3, and negative 10 times 2 is 6 plus a negative 20, negative 14? Yeah. I think it's easier to add them first and then plug in, but some of you might think it's easier to plug in first and then add. Either way is acceptable. Okay? This one says to do what? Add or subtract? Add. All right? So what's the answer? What's 5 radical x plus a negative 8 radical x? Negative 3 radical x. So where do I put the 16? In for the x, right? Which is 4 times negative 3? Negative 12. Making sense?
Yeah.
Okay? If that was subtraction, all right? What's 5x minus a negative 8x? Minus a negative 8. So we'd add them, right? So it'd be 13 radical x. So just pay attention to, if it's addition, subtraction, multiplication, or division, okay? We so far okay? Pretty easy, isn't it? Simple. All right, here's f minus g, okay? So if you want, you could do this. And do it vertically if you want. If you want to do it like that, you can. That's easier for you. You don't have to. What's 3x cubed minus 1x cubed? 2x cubed. What's a negative 2x squared minus a negative 3x squared? Minus a negative 3 is plus, so it's 1x squared, right? Positive. What's nothing minus 4x? Negative 4x. What's 5 minus a negative 2? 7, right? Because it's plus 2. So there's that answer. Now it says f minus g a negative 2. So what do I got to do? Wherever I see an x, what do I put? Negative 2. Making sense? So, negative 2 cubed is 8 times 2 is 16. Negative 2 squared is positive 4. Oh, that's a negative 2, sorry. Negative 2 cubed is negative 8 times 2, so negative 16. Sorry about that. Negative 2 squared is positive 4 times 1 is still positive 4. Negative 4 times negative 2 is positive 8, and then 7. All right, negative 16 plus 4 is negative 12, plus 8 is negative 4, plus 7 is 3. Okay? Make sense to you guys? All right, you guys do number or letter B real quick, please. Let's see how you do. Pay attention too. Sometimes they might put G minus F. Change the order. It might not always be F minus G. It might be G minus F. They might use H also for a function. Or you can use any letter. Most of the time you just see F and G though. know, I haven't done it yet. Mr. Collins says 25. You guys agree with him?
No.
Uh-oh. Taylor, what'd you say?
I said 37.
Taylor says 37.
That's right.
Rock says 35. You got 9. Okay, we better see how we did, huh? All right. So, since they're basically right on top of each other, I'm going to just do it right there. So, what's 2x cubed minus 3x cubed? Negative 1x cubed, right? What's 4 minus a negative 5? That's 9x squared, right? It's plus 5, right? What's negative 8 minus 6? Negative 14x, right? What's 4 minus a negative 9? Positive 13. So that's f minus g of x. Okay? Now, when we put f minus g of negative 1, we're putting negative 1 wherever there's an x, right? All right, so remember, negative 1 cubed is negative 1 times negative 1 is positive 1. Negative 1 squared is positive 1 times 9 is positive 9. Negative 14 times negative 1 is positive 14. And then plus 13. So what is that, 47? No, 37. Taylor was right. If you made a mistake, do you see what you did wrong? That's all that matters. If you understand what you did wrong. All right? It's okay to make mistakes as long as we're trying, right? Not yet. Let's do a couple multiplication here. All right? So, f is x squared, and g is the square root of x. So what is x squared times the square root of x? Just that, right? That's all you can do, right? So that's the multiplication part. Let's put 9 in there. So 9 squared times the square root of 9. What's 9 squared? 81. What's the square root of 9? 3. Is that 243? All right? So there's two answers, right, to this type of problem. Here's division. So F's in the top and G's in the bottom. Where's the higher exponent? Top or bottom for the X? Top. 1 is how many fourths? So I could change that to 4 fourths, right? What do I do with the 4 fourths and the 3 fourths? Subtract. So it's 6x to the 1/4. You with me there? Okay. Then we're going to plug what in for x? 16. What's 1/4 or the fourth root of 16? 2, right? So it's 6 times 2, which is 12. Get it? Got it?
Good.
Good. You guys are good. Look good, feel good? You are good, right? Do we need to do another one? I think we got it, right? Well, wait, let's do the f times here because it looks like this. Instead of radical, it was like this. So what do I do with this exponent of 1? Do I, Emma? Add the exponents, right? So this would have been 3x to the 6/5. You guys with me on the multiplication part? Just add the exponents. All right, you guys got this. Good job. There's your homework.
I don't want to. Thanks for the homework.